Hello friends, in this video, we are going to see some new things related to more utility classes. We will start with formatting time and date. One of the more powerful conversion specifier is %t for time and date. It lets you format time and date information. Okay, so it is very much powerful conversion specifier. The %t specifier works a bit differently than the others because it requires the use of suffix to describe the portion and precise format of the time or date desired. Okay, so why it is working differently? Because it is using suffix to describe the portion and precise format of the time. So the time will be displayed as precise as possible. To display minutes, you will use %t capital M, where M indicates minutes in two-character field. The argument corresponding to % specifier must be of type calendar, date, long or long. Okay, so that your time will be displayed as accurately as possible. Here is the program we will see now. Formatter object is created. Format is equal to new formatter. Then calendar object is also created. Display the 12-hour time format. Format %tr, calendar object and display the formatted output. Display the complete time and date information. Again, we are creating the formatter object. %tc calendar object display. Okay, so complete time and date information. Then display just hour and minute. %tl colon %tm calendar object. So it will be for hour and minute. Display month by name and number. %tp, %t small p, %tm calendar object and calendar object. Okay, so sample output is 9:17:15 a.m. Monday, January 1, 9:17:15 CST 2007, 9:17 January Jan 01. So depending upon your choice, which type of formatting you want to display for displaying your time, you can use the format specifier. Okay. Now the time and date format suffixes we will see. A, abbreviated weekday name. Capital A, full weekday name. B, abbreviated month name. B, full month name. C is for standard date times in string formatted as day, month, date, hour, minute, second, time zone, year. First two digits of year, capital C. Day of month as a decimal, 0131. Day, month, day, year in capital D. E, day of month as decimal, 1 to 31. F, year, month, day. H, abbreviated month name. Capital H, hour, 0 to 23, 24-hour format. I, hour, 1 to 12. J, day of year as decimal, 001 to 366. Okay, so there are 365 days. K, hour, 0 to 23. L, hour, 1 to 12. Capital L, millisecond, 000 to 999. M, month as decimal, 01 to 13. M, minute as decimal, 00 to 59. N, nanosecond, 000000000. So there are 9 times 0 and 9 times 9 for nanosecond. P, lowercase equivalent of AM or PM in lowercase. Milliseconds from 11-1970 in Q. Then R, hour, minute, second, 12-hour format. Capital R, hour, minute, 24-hour format. S is for seconds, 0 to 60. S, small s, seconds from 1197 UTC. Then time, hour, minute, second, 24-hour format. Year in decimal without century. Year in decimal including century, 0001 to 9999. Z, offset from UTC. Z, time zone name. Okay, so these are all the suffixes you will use in your program as per your convenience or as per your need. Okay, you can take a screenshot of this or you can write down this. You can learn this one by one. %n and % suffixes specifiers. The %n and %% format specifiers differ from the others in that they do not match an argument. Okay, so they do not exactly match the argument. They are simply escape sequences to place the value, insert a character into the output sequence. %n for new line, %%, insert the %sign. Neither of these characters can be entered directly into the format. Okay. Also, you can use the /n standard escape sequence to embed your new line character if you want other than %n. It is your choice. Here is an example we will see now for %n and %%. Okay, formatter object is created, formatter.format, copying file, %n transfer is %d, %% complete. Okay, so %is for new line, copying file, new line will be entered over here. After that, transfer is %d, d will be replaced by this 88. So copying file, new line transfer is 88 and this % will be replaced over here, 88% complete. Okay, so this is the output. Copying file transfer is 88% completed. Okay, so now specifying a minimum field width. An integer placed between %sign and the format conversion code acts as a minimum field width specified. Okay, integer value or a number, positive integer value or a number between % and the format specifier will act as a minimum field width specifier. This pads the output with spaces to ensure that it reaches a certain minimum length. Okay, so if there is no minimum requirement digits are available, it will add or pad spaces at the end. If the string or number is longer than that minimum, it will still be printed in full. Okay. Default padding is done with spaces. If you want to pad with 0, place a 0 before the field with specifier, so that if other than spaces, 0 will be replaced over there. For example, %05d will pad a number of less than 5 digits with 0 so that its total length is 5. Your output is suppose 0.32. So, and your minimum width is specified is 5. So it will be like 0.32000 if you specify 0 other than spaces, or if you do not specify 0, only %5d, it will be placed as 0.32 space and space. Okay, so that total length is 5. The field width specifier can be used with all format specifiers except %n, because %n is not actually for the replacement of a value. It is just for inserting a new line character. So now we will demonstrate the minimum field width specifier for %f. New formatter object is created. Formatter.format %f, %n, %12f, %n, %0212f. Okay. So first %f will be for 10, 1, 2, 3, 4, 5. Then 10, 1, 2, 3, 4, 5 for this %12f. Okay, and %0, 1, 2, f. Okay, so it's 10.12345 for the first. Second, 10.12350. Okay, and the last one is 000, because you have specified here 0, and 10.123450. The first line displays the number 10.12345 as a default width because you have not specified any width. The second line displays the value in 12 character field. Okay. Okay. And the third is display the value in 12 character field padded with leading zeros. Okay. So 12 character field is like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 12 character field is there. with this point added over here and padded with zeros. Okay, reading zeros. The minimum field width modifier is often used to produce tables in which columns line out. Okay, so output should be one below another in those tables. So to produce this type of tables, minimum field width modifier is used. For example, next program produces a table of squares and cubes for the number between 1 and 10. Formatter or from 1 to 10 incremented by one new formatted object is created. %4D, %4D, %4D. I will be 1, starting with 1. I into I, 1 into 1, 1 into 1 into 1. Like 2, 2 into 2, 4, 2 into 2, 4 into 2, 8. Like this. Okay. So 1, 1, 1, 2, 4, 8, 3, 9, 27. So these are tables generated. First is 1's table. Then 1, 4, 9. So square table is generated. Table of square and cubes. First is nothing. Only 1 to 10 are here. Then squares are generated. 2 square is 4, 3 square is 9, 4 square is 16. And for cube, 1, 8, 27, 64, 125, 216, 343, and so on. Okay. So for that purpose, formatting is specified. Okay. %4D, %4D, and %4D is specified over here. Then specifying a precision specifier can be applied to the %F, E, G, and S. It follows the minimum field width specified if there is one and consists of period followed by an integer. Okay. %F follows the minimum field width specified. The exact meaning depends upon the type of data to which it is applied. When you apply the precision specifier to floating point, it determines the number of decimal places displayed. %10.4F displays the number at least 10 characters wide with 4 decimal places. Okay, 10 characters minimum with 4 decimal places after point. When using %G, the precision determines the number of significant digits. The default precision is 6. Okay. Applied to strings, the precision specifier specifies the maximum field length. For example, %5.7S displays a string at least 5 and not exceeding 7 characters long. Maximum field length not exceeding 7 characters long, at least 5. Okay, so minimum is 5, maximum is 7. If the string is longer than the maximum, the end characters will be truncated or deleted. The following program we will see now for the precision specifier. Formatter object is created %.4F 123.123.4.67. Okay, so 4 decimal places 1, 2, 3, 4. Format to 2 decimal places in 16 character field. 16 character .2E. So 2 decimal places will be kept over here, and formatting with Java is now easy. Okay, so what is the meaning for string? At least 5, maximum 7. So here also at least space maximum is 50. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay, so maximum 15 characters long, and all other is truncated over here for the string formatting precision specifier. Okay, next, using the format flags. Formatter recognizes a set of format flags that lets you control various aspects of conversion. Okay, all format flags are single characters and a format flag follows the % in a format specification. So now we will see the format flags, and those control various aspects of conversion, and those are single characters, and a format flag follows the % in a format specification. dash left justification, hash alternate conversion format, 0 output is padded with zeros rather than spaces, space positive numeric output is preceded by a space, plus positive numeric added output is preceded by plus sign, then comma numeric values include grouping separators and opening parenthesis, negative numeric values are enclosed within the parenthesis. Okay, note all flags apply to all formats specified. We will see those one by one in detail. Okay, justifying output. So what is first is dash left justification. So we will see then first all output is right justified if the field width is larger than the data printed. The data will be placed on the right edge of the field. Okay. Total field width is larger than the data that is printed. It will be outputted on right edge of the field. You can force output to be left justified by placing a minus sign directly after the percent. Okay. So percent minus 10.2f left justifies a floating point number with 2 decimal places in 10 character field. Okay, so I'm sorry, this is not a dash, it is actually called as a minus for left justification. Okay, so now we will see the left justification. Format object is created in a class left justify, then right justify by default. Formatter.format %10f.2f 123.123. Output is displayed. Now left justify, again formatter object is created, minus 10.2f 2 decimal places in 10 character field, and it is left justified. Okay, and output is 123.12. It is right justified by default, and left justified is displayed over here. The second line is just left justified within 10 character field. Okay, so it is intentionally keep as a left justified. The space plus 0 and opening parenthesis flags. To cause a plus sign to be shown before positive numeric values, add the plus flag. Example, formatter.format %+d100. Okay, so that plus sign will be shown before positive numeric values. Create the string plus 100. So your 100 will be preceded by plus sign. When creating columns of numbers, it is sometimes useful to output a space before positive values so that positive and negative values line up. Okay. When creating columns of numbers, it is sometimes useful to output a space before positive value so that positive and negative value line up in a one column. Okay, so that you will understand what are the positive values and what are the negative values. To do this, add a space flag. Okay, so space flag is added over here. Demonstrate now. We will space flag. Formatter object is created, minus 100 %space d. Okay, so that minus will be placed at accurate place so that they can be formatted in a column wise output. Okay, so 100 and 100 will be lined up in a formatted manner. So here we are added a space after this percent. Here also we have added a space. Okay, then again formatter object is created, %space d minus 200 out println format and 200. Okay, so output is minus 100 plus 100 minus 200 plus 200. Okay, positive values have a leading space which causes the digits in the column to line up properly. By default, we should show negative numeric output inside parentheses rather than with leading. Minus, use the opening parenthesis flag. Okay, so positive value by default have a leading space, and for negative numeric output inside the parenthesis you have to go give the parenthesis opening parenthesis with the leading. Minus, use the opening parenthesis flag. So how it is written, % opening parenthesis and d The zero flag causes output to be padded with zeros rather than spaces. Okay, then comma flag. When displaying large numbers, it is often useful to add grouping separators, which in English are commas. Okay, so grouping separators means to understand the value better. For example, 1, 2, 3, 4, 5, 6, 7 is more easily read with 1, 234, 567. To add grouping specifier, use the comma flag. For example, formatter.format per set, comma, point to f. So, 2 decimal places after point, comma is given. Okay. Output is 4, 356, 783, 497 plus 0.30. Okay. And the next is hash flag. The hash can be applied to octal, hexadecimal, exponent, %f, float. For E and F, the hash ensures that there will be decimal point, even if there are no decimal digits. Okay. If you precede the %x format specified with hash, the hexadecimal number will be printed with the 0x as prefix. Preceding the octal specified with hash causes the number to be printed with the leading 0. So output for each and every specifier is different. More important thing is you have to learn them. You have to practice them so that you can understand and remember. If you precede the %x format specifier with hash, hexadecimal number will be printed with 0x as prefix. And for octal specifier with hash causes the number to be printed with leading 0. Okay. Then next is uppercase option. Several of the format specifier have uppercase version so that cause the conversion to use uppercase where appropriate. So now we will see the effect. %A causes the hexadecimal digits through F to be displayed in uppercase as a through F. Also, the prefix 0x is displayed as 0x and the P will be displayed as capital P. %B uppercase is the values true and false. %E causes the E symbol that indicates the exponent to be displayed in uppercase. Okay. %G causes the E symbol that indicates the exponent to be displayed in uppercase. %H causes the hexadecimal digits A through F to be displayed in uppercase as A through F in a capital letter. %S uppercase is the corresponding string. %T causes all alphabetical output to be displayed in uppercase. %X causes the hexadecimal digits A through F to be displayed in uppercase as A through F capital. Also, the optional prefix 0x is displayed as 0x if present. Okay. So, %X250 creates the string FA capital. This called formatter E123.1234 creates the string E as a capital 123123 E plus 0. Okay. So this way we have seen so many interesting topics related to utility classes. Okay. Our journey will keep like this only for next upcoming session. Maybe one session. And after that, we will move forward for the practical part. Till then, you can practice, you can enjoy the session, you can learn them, you can remember them, and take down the notes. Okay. So meet you in the next session with the new topics in utility classes. Thank you so much.